Okay, so now you got introduced to creating classes and objects in Python. Let's take a step further and let's see what happens when you create an object and if you want to customize something or if you want to do something while creation of an object, what can you do? So in all object-oriented syntax, there's something called as a constructor. What is a constructor? When you create an object from a class, the first function that gets called is the constructor. So if you look at the example that we saw in the last class, if you look at this was the example that we're looking at. Beside message one is the object name, hello is the class, and we called here hello with the parenthesis hello. Now what is actually happening is this hello class is creating an object by name message one, and internally there's a function called as constructor which is defined for all classes. Right? So whenever an object gets created by default, the first thing that is done is calling the constructor function. Right? So that is why we see the parenthesis here. So because it's like calling a function, we are having the class name with a syntax that similar looks very similar to a function call. Primarily, this is internally calling a function called as the constructor. In Python, this constructor is given a very specific name called as init. So the syntax is underscore underscore init underscore underscore all in small case. So in the PPT it looks capital case, but in the program when we write, we'll write all in a small case underscore underscore init underscore underscore. So and this is a normal function. I mean, everything we write inside it's like a normal function, but the name is very specific. So let's see how it looks in actual. So this is df define a function by the name underscore underscore init underscore underscore, and you have to pass the default parameter called as self, which we saw in the last class that all functions that all methods which are created inside a class receive a default parameter called as self, which is pointing to the object itself. So this receives a self parameter, colon operator, and then the indentation to start with my function init. So when we execute this line of code, it by default goes and calls this init. So we can see we are not calling the init anywhere here. The call of this init happens by itself. So this function is called as a constructor function, or the function which you can view it as the function which constructs the object. Right? So if you execute this code, let's debug it to see how the flow of the code goes. Okay, so we are coming to the beginning of the function. So this is the first call, message one is equal to hello, and okay, we did not step into it, so let's step into it and see where. Let me stop the debug. I'll restart it once more. Okay, let me step inside. So when this call gets executed, message one is equal to hello. You can see the control has come to this constructor. So you can see nowhere in this program did we call this function underscore underscore int underscore underscore. But when we executed this, the control went from here to define init, the function def init. Right? So now if I continue with this, it executes this init function and then comes back to the, so you can see it's printed created the object, right, and then comes back to the main part of the code. Right? So this line basically what it did, it went to the definition of the constructor, executed the constructor and came back. And when it did come back, we can see the message variable explorer. It came back with the object by the name message1. The object msg1 is of type hello because that is the class which you have created. The size and all are not relevant to us right now, right? So even if for message 2, msg2, if we step into it, you can see that it goes into definite again. So as soon as I call this, it executed this init function. Now you have to remember that this init for hello message 1, MSG1, and this init for MSG2 are different because they're two separate objects. So it's going to execute the same, it's going to show the same output, but this basically create the second object. Right? And then it'll come back to this and continue with the remaining part of the code. Right? So it printed hello Python and hello Java. Right? So this init is the it's not mandatory to have it. So in the previous codes that we wrote, we did not have an init. So if it is not there, internally a blank init is created, which does nothing. It simply goes and creates the object and comes back. Here, but generally in a practical scenario, when you create an object, you would want to initialize some variables. You would want to have some default values given to some variables. So that is why, or you would want to print some welcome message that okay, welcome to this object, or welcome, the object has been created, some message to show that what did you do. So because of those initialization things which you don't want to have it as a separate function call, you can put it into init, so it automatically gets called. Whatever needs to be done at the beginning of the object creation gets done in the init, and then it comes back with the reference to the object that gets created. Right? So now this init can receive parameters like any other method that we or function that we have used. So for example, here I am calling init, self is the default parameter, and I'm passing a parameter called as name. Now what are we doing here? We are saying hello, the class name, and we are passing a string called as msg1, which is basically the object name. I mean, you can pass any parameter you want here. We are passing msg1. So what happens by default when it gets called, self is the object reference, name is the msg1 that gets passed as the name. So it gets printed is created the object, uh, whatever name we are passing to it. Alright, so that is how you pass the parameter. Similarly, I'm saying msg2, hello msg2, so it gets called here, and msg2 gets passed here, and it prints the msg2 as the created the object name, and comes back and returns the reference value msg2. Right, so maybe we can step through this also once just to see how it functions. Uh, okay, let me step inside. So init gets called with self and name as the parameter. So I execute the print statement, created the object msg1. So that is what we have passed here, and it comes back from there msg1. And if I step into it again while creating msg2, so you can see it prints created the object msg2, which is the second object that we passed here, right? Second string that we passed while creating the second object, and then it comes out of that and continues with the remaining code. So if I go to variable explorer now, I can see msg1, msg2 both have been created, and you can see the print message relevant to that object creation, because this message got printed while creating msg2. This is this function call, right? Then it continues with the normal print. So now we are passing a variable here called as Java, which gets passed as a variable here, and it prints hello Java. So we can pass a argument to the method also. So method is basically a function. So we can pass some variable to it. So I am passing a variable here to the function print hello. So msg1.println receives Java as a variable which gets received here, and I can use this variable inside this within the flower braces. So because this is a parameter being passed from here and it is being received as a parameter in the function call, we need not put a self tag to this. Okay, we'll see that when we create parameters specific to the object later, we'll be using a self tag for the variables also, but here it's not required. And so I'm passing a parameter called Python here, and that gets received here, and it prints the hello Python. So you can see the output when we execute it. So you can see hello Python got printed here, hello Java got printed here. So whatever parameters you pass from these two, that will get while calling the print hello, that gets printed here. Right. So now these functions are methods are basically functions. So whatever is possible in a function is possible in a method also. So that is something you have to remember, that other than the parameter self which we have to pass compulsorily, anything else that you pass after that is just a normal function parameter. So we can use it as a normal function parameter inside the function. Right? So let's take a little more bigger example just to get the concept clear. Right. So now, before I go to a bigger example, let me take example where we have a variable in the class itself. Now, obviously, a class might require to store data, right? For example, when we were introducing the concept of class and object, we said we have a class called a student who has a name and a USN and a uh, end of method. Fine. So the name and USN becomes variable. So where do we store such variables? So all those variables which are specific to an object get initialized in the init part. So we have self dot var is equal to x. So var is the variable which is specific for this hello class. Okay, so when I create an MSG1 object, it gets its own variable called as var. So you can see it is self dot var. So it is saying this variable var is part of this object self, and I am passing the number 10 while creating the object. So this 10 gets passed as parameter to the method and init method, and that 10 gets assigned to var. So in the rest of the class anywhere, I can use this self.var as a variable, and the value that I've assigned here will be available to me. So whatever I've initialized in the init part, that value will be available to all the other methods which are present in this class. So MSG1, we have said hello 10. Now when we say MSG1 print hello, in the print hello method, we are printing the self.var. Self.var is what? The variable that we initialized here in the init function. So this var is actually the variable name. Self is the keyword which you're attaching to it to make sure it is specific to the object on which we are calling it. So when you say hello 20, so second object msg2 gets the value 20. So the var inside the object 2, which is msg2, has a value 20. So msg1, msg2 both have variables called var, but the value inside MSG1 becomes 10, the value inside MSG2 becomes 20. So when you execute MSG1 dot print hello, it will print hello 10. MSG2 dot print hello, it will print 20. Okay, so let me just run this and show it to you. Stop the previous debug and then run it. So you can see first created the object for the MSG1, created the object for MSG2, then hello 10 and hello 20. So hello 10 is the print hello which we called on the first method, print hello which printed hello 10, and then the second msg.print hello printed 20, because while creating the message msg2 object, we had passed 20 as the value, right? So hope using the variable is clear. We'll take a few more examples for this, but I hope that how we can, now this as a Python we are not declaring any data type. So self dot var is also need not be any. We are not declaring any data type. Whatever value you assign to it, it becomes data of that data type. Right. So if I take a slightly more, mm, okay, yeah. So let's take a little bigger example now. So let's say I want to maintain the create a class of a bank account. Right. So generally an account, for example, now we are taking an account will have a name and a balance, account name and account balance. Fine. So initially when we create an account, right? So by default we would want to give the account name and account balance as soon as the account gets created, right? So what we have done, we have taken a class account. Inside this is the constructor def init. It is receiving name and balance while creation of the account. Now balance, by default we're assigning a value of 0. This is the default parameter. We're giving a value of 0. So if a value gets passed while creating the init, it will be taken. If it is not passed, it will be taken as 0. So whatever name comes here, that becomes the name of the account. So you can see this is self dot name is equal to name. So this name that you see in the right hand side is the name of that we're receiving as a parameter. On the left hand side, what you see is the name, self dot name is the variable of this class. Right? So please note the difference. The variable name is same. Okay, it's also name, there's also balance. Name here and balance here. But the difference being this has self dot balance and this is self dot name. So the self dot name is a variable for this class. So any object that gets created from this class will have a variable called as name and a balance. These two variables are variables which we are receiving as parameters. Now this can be renamed to anything you want. If you want, if it gets confusing, you can just simply call it n. Does not matter. Alright, so that is also okay. But it always is a good practice to give variable names which make sense. So then we have a method called as show balance, which will display what is the balance. So if you want to display the value of this balance in the account, it will be self dot balance, balance of whichever account we're trying to access. And then we have a method called as credit, which will add amount to the balance, whatever parameter is passed, and call it debit, which will deduct amount from the balance. Right? So let's see how we have written this. So account one we have created is equal to account is the class name, right? So this is the class name that we have here. So we are creating an ACC1 object of the type account and we are passing a parameter ABC. Now because this is the first parameter and which gets assigned, which directly gets passed to the variable name. Now we are not passing a second parameter which is the balance, so it takes the default parameter. So when this line gets executed, it gets executed um, by and creates a object ACC1 which is an account having the name as ABC and the balance as 0, right? Then we create account 2, ACC2, another account with the name XYZ, but now we are passing a parameter 200 for balance. So this time ACC2 gets created with the name XYZ and the balance of value 200. So XYZ gets passed here, balance becomes 200. Now if you want to print out these values, you can just show, yeah, if I can print the value ACC1 dot show balance and print ACC2 dot show balance. Alright, so let's see. Now let me execute it step by step and see how things go here. So first you come to this line. Uh, Let me go into it. So it calls the init function and name gets assigned to self dot name, balance gets assigned to self dot balance and comes back from there. Okay. Now you can see the variable explorer. You have account one, which is of type account. Okay, and you can see the value balance is in it, and there will be the parameter called as name. Name is ABC. Right? You can see the name part here and the balance part here. Balance part here, which is 10. Right? So that's the first step. So we created ACC1. If we do the same thing for ACC2, I'll not step into again. Let me directly create the step 2. I get created ACC2 which has a balance of 200 and the name of XYZ. So now I have both these objects ready, ACC1 and ACC2. Both are of type account and both have different names and different balances. So if I execute the next step, the balance is 0. All right. That is the first account that we created. Alright, and then if we execute the next, the balance is 200. Alright, so did we print something else here? The balance is 200. This none is coming from where? Show balance self. Okay, let's check that later. Fine. So the balance is 200. Fine. So that is the those two steps that we have created. Right. Now I have another function here. Now, please note this is not a method. We have a function called as update balance. Now, what is this doing? Now we want to update the balance of a specific account. So we are passing the object as a parameter. Right? ACC1 is being passed as a parameter. So because it is just a data type of the type account, you can pass parameter as an uh, any value as a parameter in a method. So we are passing ACC1 as the parameter. So the update balance method, we have it here. It is receiving ACC, and then we call the method acc.credit. So we are crediting something into the account, a value of 100. So you can see it calls this method with value of 100. Inside this, what are we doing? Update the balance. That is balance of which account? ACC account. Which is ACC account? It is ACC1 account. Right? So ACC1 dot balance gets updated with ACC1 dot balance plus whatever variable you have passed here, which is the x value. So we have passed x value is 100. So it becomes ACC1's initial balance was 0. So 0 is equal to 0 plus 100. It becomes 100. And then if you print ACC dot show balance, it should print the value of 100. Right? So let me step into it and let's see what happens. You can see it calls the AC update balance. Let me step there. It comes to acc.credit. If I step into it now, it will go to the credit method of this class. Right? Now I'll step it'll the current balance is the value of x is 100, and inside ACC1 if you look at the current balance is 0, right? So let me execute this step. Alright, so it updates the balance and comes back. So if you go to ACC1 now, you can see the balance has become 100. 0 plus 100 is equal to 100. Alright, so and I can print the value of show balance. It prints the value as 100, right? And then return from there. That's it, the end of the function, right? So you can see that we updated the balance, and the ACC1, the ACC that got created temporarily here is no longer available to us here because we exited the function. But you will be able to see that the value got updated in ACC1 also, because in Python the when you pass the object, it passes the reference to the object, and whatever changes you make to the object here, it changes the original object also. So unlike C, you must be used to the concept of passing by reference and passing by value. Here you can assume unless and until you do it specifically, you by default send a copy of an actual copy of the reference to the object. So whatever change you do to this account here or the variable in the balance, when you're passing an object, not any variable, when you're passing an object, the same changes are visible to you when you come out of the function also, because an object is not passed as a value, the reference to the object is passed. So because it's a reference to the object, any modifications in the balance in the object will be visible even when you get out of the uh, function which did the modifications. Fine. So that's a slightly bigger and complicated example. I hope you got the concept better uh, of how to create variables in it and in a class, how to use them, and how you can use function to pass an object as a parameter, and how you can modify the parameters of the object, and changes or made in the function, how they are visible even when you get out of the function. Let's hope that concept is clear. Thank you.